Hello again. Thanks for watching this video and for studying your math. Remember that reading your book is important. The examples there are different than the examples I will use, and it is important to pause, play, and rewind the video to get the maximum benefit for the examples that I do. In a similar way that we can multiply binomials to get a trinomial using foiling, and as we can take a trinomial and factor to get a product of binomials, we also can add this rational expression to get a simplified rational expression. Partial fraction decomposition starts on this side and goes over to the other side. The reason we do this is because in calculus this is a powerful technique for determining integrals of rational functions. Here's the description in your book. You may want to pause and read that or read it separately in your book. Many of my students, however, have found this to be a little simpler. Partial fractions can only be done if the degree of the numerator is strictly less than the degree of the denominator. If that's not the case, do long division until it is. Once we've determined we can do partial fractions, we factor the denominator as completely as possible. Then for each factor in the denominator, we use the following table to determine the terms we pick up in the decomposition. So for every linear factor looking like this, we get a term in the partial fraction decomposition looking like this. If that is raised to the kth power, we get k terms that look like this. If it is an irreducible quadratic form, meaning it cannot be factored, then you get a term that looks like this. Notice that this is ax plus b. And if that's raised to the k power, you get k terms exactly like that. Examples will help make this much clearer. Here's the first example. Please pause the video and do the problem. Let's see how you did. Well, we have a degree of 2 in the denominator and 3 in the numerator, so we have to do long division. We do long division and we'll get the 3x, but this is the remainder that we can apply for partial fractions. So we do partial fractions on this. We have factors of x and x minus 1, so this is going to be a over x plus b over x minus 1. So I get a common denominator here and equate the numerators. So a plus b is the coefficient on x after you simplify. So that means a plus b must be 7. And minus a corresponds to the minus 4. We solve that system of equations and we get this. And that tells us that the total partial fraction decomposition is this one. Let's do another example. Please read the example and pause the video. Let's see how you did. Now here I have a linear factor in the denominator raised to the third power, so I know this is a plus b plus c over these denominators. So what I will do is get a common denominator and equate this with the numerator. So what I see is that a corresponds to the 1 up here, so a is equal to 1. Minus 6a plus b corresponds to the minus 4, and we see that 9a minus 3b plus c corresponds to the 7. That's the constant. So a is 1. Here I substitute a to be 1, so b ends up being 2 and c is 4. And this is our partial fraction decomposition. Here's another example. This one is featuring a linear factor and an irreducible quadratic factor. Let's pause the video and see how you do. So here is a solution. So I set this up. This is the form that it matches. Notice I put bx plus c over the irreducible quadratic form. So I simplify and equate the numerators. So a plus b corresponds to the 8. 4b plus c corresponds to the 10. And a plus 4c corresponds to the minus 3. I solve that system of linear equations, and this is my partial fraction decomposition. This is our final example. Notice that we have a linear factor that's just x or x minus 0, but here I have an irreducible quadratic form that is squared. Pause the video, let's see how you do. So here I end up with 2 of these linear factors in the numerator. I have a over x plus bx plus c over x squared plus 1, and then I have dx plus e over x squared plus 2 whole squared. So what I do is get a common denominator and I equate the numerators. So a plus b is going to correspond to the 1. C is going to correspond to the 3. 4a plus 2b plus d is going to correspond to the 4. 2c plus e is going to correspond to the 2, and 4a is going to be the 4. I solved this system of linear equations to find these are the solutions, and that means the partial fraction decomposition is given here. Please ask questions if you need to. And here's a summary in your book, and I encourage you to pause the video and read it. In closing, remember, time is precious. Each day must count. Do the math. It will make you strong. See you tomorrow.